Hello everyone, welcome to this video tutorial series on Java Technologies Lab. So today we are going to look at program 9. Okay, so the aim of program 9 is to write a Java program for converting an image which is in RGB to a grayscale image. Okay, so simply what we are going to do is we are going to convert a colored image into a black and white image. Okay, so grayscale image means black and white image. Okay, so before going to see the program, let's see some theory. So first let's discuss about color models. So if you take any image processing application, uh, you will need to represent colors as numerical values. For example, if you take red, you want to represent red color as some value like 120, 130, and so on. Okay, so for representing the colors into numbers, we will use different models. Okay, we are going to use some models for defining numerical values to different colors. Okay, mm, generally, if you take different models or popularly used models, typically the model contains three or four components. Okay, so let's see the first one, RGB model. Okay, so in the RGB model, uh, any color you take, it will be represented as a combination of these three RGB. So RGB means red, green, blue. Okay, so this is the most popular model. Mm, and you take any color that is orange, yellow, okay, for example green, pink, magenta, whatever color you take, it is represented as a combination of red, green, and blue. And these three components will have a value which ranges from 0 to 255. Okay. Mm. So for example, you see this, so we have three components: red, green, and blue. Now, if you take this corner of this cube, which here it is saying it is white, okay, white color. So this white color is represented using the red, green, blue, whose values are 255, 255, 255. So this first 255 is red, second 255 is green, and third 255 is blue. Okay, similarly, whatever color you take, for example, here there is some light green color, it is also represented as a combination of different values given to red, green, and blue. Now, for example, if you take this left corner, which is red, it is saying the red is 255 and other two components, blue and green, are 0 and 0. Okay, so similarly, we will have different other models also. And next one is grayscale. Like I told you, grayscale means black and white. Okay, it is the simplest model that is there because it contains only one component, right? And that component represents the lightness. Okay, and again the values range from 0 to 255. So here you can see 0 means black and 255 means white. Okay, so why grayscale is simple and popular is because it requires less amount of storage to store the values because there is only one component to store, and also it is faster. Okay, right. So this is the grayscale spectrum. You can see 0 is black, 255 is white. In between 0 and 255, you have different shades of gray. Okay, that's why it is called grayscale, right? And what are the different other models is, so one another popular model which is used in web designing is CMYK model. Okay, C means the color cyan, M means magenta, Y means yellow, and this K means black. So actually K represents key, which is the black color. Okay, and there are some other models like HSL and HSV, which are frequently used by artists. Okay, so HSL means hue, saturation, lightness. Okay, and here again HSV means hue, saturation, and value. Okay, right. Now, how do you convert um, an image which is using RGB model to grayscale? Okay, so different researchers have done different works on this, and finally they have arrived at this formula. Okay, so from the existing image, and for each pixel, you take the red component, multiply it with 0.3, take the green component of the pixel, multiply it with 0.59, and take the blue component of the pixel and multiply it with 0.11. Now you add all these three values and you will get the grayscale value for that particular pixel. So an image is made up of different pixels. Okay, pixel, right? Okay. So here is the input image that I am going to use in the program. I will demonstrate the program in a few seconds, but before that, let's see the input and output. So this is the input. So this is the RGB image that I am going to use. So I am a big fan of the Naruto Shippuden anime, so I am using that picture of Naruto. And the output is the black and white version, which is our grayscale image. Okay, so this is the mm, so that's it about the theory part. So let's close this and move on to the demonstration. So first of all, mm, you have to create a new Java project. Okay, go to File, New. Um, I think you have to click on this Other. Okay, and mm, this one Java project. Okay, click Next. Give some name. Okay, here I have given the name RGB demo, so you can give some name here and click on Finish. Okay, so that's all. Why we are creating a Java project instead of a dynamic web project means this program does not deal with any web application. Okay, this is a simple Java application, so you have to create a Java project. Okay, now right click this project that you have created, click on New and click on Class and give the name as driver. Okay, so for me it is saying type already exists because I have already created the file. For you this will not show any error like this, and click on Finish. Okay, once you click on Finish, you will get this file. Okay, of course you will not have any code in this, it will be empty. Anyway, this entire code will be shared in the description of this video. You can get it from the description. Okay, now let's observe this program. It is not a big program, it's a small program. So those who are familiar with core Java, they will know about this package java.awt, and they will also know about java.io. Okay, so the new things that you might be mm, seeing here is one is java.awt.image. So this is one package that we are using, which contains the buffered image class. And the another thing is we are using javax.imageio package, which contains image IO class. Okay, so these are the new packages that you might be seeing here, uh, which you might not have learned in core Java. Okay, so create the class driver and create three variables. So first variable is image variable img, which belongs to the buffered image class that we have already imported here, buffered image class. And two other variables are integer variables, the width of the image and height of the image. Now create the constructor for the driver class. This is a constructor. Now use a try block. Okay, so this entire thing is a try block, this highlighted thing. Okay, right. Mm, Now within the try block, first create the object for file class. Okay, we are creating a file object called input, and for which file we are creating this object is naruto.jpg. So if you see on the left hand side, I have already uh, inserted this image in my project RGB demo. So what you have to do is, so download some image like this from the web, from Google or somewhere. Okay, so it is on my desktop. So once you download the image on your desktop, right click the image, click on copy. Okay, come to the Eclipse, right click the project name. Okay, right click the project name and click on paste. Okay, just copy the image and click paste on the project. Then you will automatically get the image here. Okay, so that is this. Now you have created the object for the file class. Then you are using the image IO class, which you have already imported at the top. Okay, now in this class there is a method called read. Okay, so basically what does this method do is it reads the data from the image. So where is the image? Here is our image, which we can reference using input. So the same thing we have specified here also. Image IO.read input, and whatever it has read, it will be stored in this img mm, object, which belongs to buffered image. Okay. Now using this reference, get the width and also height. Okay, width of the image, height of the image. Now what is the use of this nested for loop is, so as I already told you, a picture consists of different pixels. Okay, you can imagine a picture as a matrix. Okay, you can imagine a picture as a matrix where each cell in the matrix is a pixel. Okay, so as you, I think all of you have already worked with matrices in Java. So how do you work with a matrix? You will use a nested for loop, right? For row and for column. Okay, similarly here you have height and width. You can think of this as number of rows and this is number of columns. Now for each pixel, okay, what do I mean by for each pixel means this one. So pixel can be represented using this I comma j for each cell in the matrix, or you can say for each pixel in the image. You are getting the color of the pixel by using img dot get RGB. Okay, so what you are doing using this code img dot get RGB is you are getting the current values of red, green, and blue for the pixel. Okay, now once you get the current value, that is which is already in RGB, how do you convert it into grayscale? So just now I have given you the formula for converting RGB into grayscale, right? So just I am applying those values here. I am applying the formula. Okay, so red, for red we are saying c dot get red. Okay, so what is this c? This is the c. It's the object of the color which contains the current values of RGB. So from the RGB we are getting the red value and we are multiplying it with 0.299, which is 0.3. Okay, so similarly you are getting the green component and multiplying it with 0.587. Okay, similarly you are getting the blue value and you are multiplying it with 114. So the new values of RGB are stored in the variables RGB. Okay. Now you are creating another object for color class, and you are specifying the values of red, green, blue as the sum of R plus G plus B. Okay. So now once you created this new color, you have to set it. So how do you set that? By using another method called set RGB, which is available in the buffered image class. Okay. So for a particular pixel which is in the location ij, you are going to set that value by using set RGB. Okay. So that's all. That is the program. So once the execution of this nested for loop is completed, that means your entire uh, colored image which is in RGB model is converted to grayscale. Now once your image is converted to grayscale, you have to store it somewhere, right? So for storing, we are creating another variable called output, and we are giving a new file name called graynaruto.jpg. So you can give any name, but I have given the name graynaruto.jpg. So once you have created the object for the file, then you can write the image by using the class ImageIO and the method write. Okay. So there are three parameters here. First one is the buffered image class, which is having the actual grayscale image img, and second one is the type of file you want to create, which is jpg. So I have given jpg here. And third one is the file reference or the file object, which is output. Okay, that's all. So after try block is completed, you can write the catch block, and if you want to write any code, you can write, but I have not written any code. Right. Okay, so this entire code is the constructor. Okay. Now we have main method also, where simply I am creating the object for the driver class, right? Which will instruct, which when this line is executed, what will happen? The constructor is executed, right? So this entire code is executed whenever the object is created. So that's it. That's the program. So if you see on the left hand side, there is only naruto.jpg, right? But when I run the program, mm, okay, so I think the program has already executed. Now if you don't see the output, that is the gray naruto.jpg here, just right click the project, click on refresh. Okay, so I think the program didn't run. Let me run it again. Okay, right click, refresh. Okay, so I am not in the Java perspective. Now I have shifted to Java perspective. So let's see again. Run. Right click, refresh. Okay, so the output is not created. Driver. Okay, so we can't see what is happening. Just let me write a println statement and see what is happening. So let me just write done. Okay, now let's run the program. so it didn't run. Hmm. Mm, let's try it in the try block. Let's run again. Okay, so this time it is saying done. Okay, so instead of this, let's use the exception handling and write something in the catch block. Let's do e dot print stack trace. Okay, so it's saying coordinate out of bounds. Array index out of bounds exception. Hmm. I think we are getting that from here. So let's write j comma I, and here also j comma I. Now let's run the program. Okay, this time I think it has executed. Right click, refresh. Ah, yes. Now we have got gray naruto.jpg. You can open it and see it's a black and white image, right? Okay. Whereas naruto.jpg is a colored image, and this gray naruto is grayscale image, which is black and white. Okay. Uh, right. So that's it. That's the program. So this is how you convert a colored image to a grayscale image. Okay. Thank you.